Let's see how to find the area of figures that are made up of multiple shapes. In this first example, what are the two figures? We obviously have a rectangle here and a triangle there. We need to find the area of both and add them together to find the area of the entire figure. So I'm going to start by finding the area of the rectangle, which I use the formula base times height. So the area of my rectangle is going to equal 6 times 5, which is 30. Now for our triangle, we're going to use the formula area equals 1/2 base times height. So in this case, I recognize my base and height because they're perpendicular to each other. So I'm going to multiply 1/2 times 2 times 4. The 1/2 and the 2 cancel, and I'm left with an area of 4. Therefore, my entire area is going to be 30 here and 4 here. So my total area is going to be 30 plus 4, which equals 34. And if you want to write a units, you can put a U for units, or you don't have to write units since none are given. Let's go to the next figure. Now in this figure, we're going to split it up using the grid, and the grid will help us to count. And you can split this figure up different ways. I'm going to start by splitting up this figure this way. I'm going to make a triangle there, and then we have 1, 2, 3, 4. So we have a trapezoid as our other figure. So I'm going to find the area of a triangle. And so the area of a triangle is 1/2 base times height. Now if I look at my triangle, my base and height have to come together to form a right angle. So my base and height will be these two sides, where each of the sides is 1. And I can tell that it's 1 because it's one side of a square. So I'm going to multiply 1/2 times 1 times 1. So the area of my triangle equals 1/2. So next I'm going to find the area of my trapezoid. Now if I want, I could actually split that into more figures, but I'm going to do it as a trapezoid for this example. So the area of a trapezoid is 1/2 the sum of the bases times the height. So in this particular case, the bases are always the parallel sides. So my bases are 1, 2, 3, a length of 3, and 1, 2, 3, 4, a length of 4. My height is the perpendicular distance between the two bases, so I can pick any of the lines that connect the two bases. I'll pick this one right here, and it has a length of 1, 2, 3, 4, so my height is 4. So I'm going to plug in my numbers into my formula for the area of a trapezoid, and I get 1/2 the sum of the bases, 4 and 3, times the height, which is 4. And then I just do my math. You can put this straight into a calculator. So 4 plus 3 is 7. Half of 4 is 2. 2 times 7 is 14. So the area of the trapezoid is 14. So if I add all this together, I have 14 for the area of my trapezoid and 1/2 for the area of my triangle. Therefore, the entire area is 14 plus 1/2, which equals 14.5. Now another way that you could split up this figure, if you wanted, might be to come in and do a triangle here, a triangle there. So we have two triangles and a rectangle. So there's different ways you can split up these figures, and you should always get the same area regardless. So let's look at another example. In this particular example, you could approach it a couple of ways. First of all, the figure that is inside here is not a figure that you can use a formula for. So that's just a quadrilateral, but it's no particular type that we have a formula for, so we can't just go in and find the area of that. So what do you think you might do? Well, what I would do is I would find the area of the rectangle and then subtract the 4 triangles away from it. So that's what we're going to do. So we're going to find the area of the rectangle minus the area of each triangle, and there's 4 triangles. So the area of a rectangle is base times height, and in this case you're going to use the sides of your rectangle to count. So take a second and count those and see if you get what I get. And then just fill in the numbers for base times height and multiply to get the area of the rectangle. And then do the same thing for each of your triangles. And remember your triangle formula for each of those. So go ahead and see if you can figure this problem out. Pause this for a minute, figure it out, and then play it to see if you got it right. So here you'll see that I've used some color to help organize my work. I found that the rectangle was 13 by 10, so it has an area of 130. Then you'll see I have a purple around this big triangle, and I found that it was 11 by 7, and so for my formula 1/2 base times height, I did 1/2 times 11 times 7 and got 38.5. And in green you'll see a triangle where I have the sides of 2 times 4, and I got 4. And then in blue, I used the formula and had 6 times 10 for the sides and got 30. And then in yellow, for the smaller triangle, the sides were 3 by 3, and I ended up with 4.5. So then I'm going to add all of my triangles together, which you'll see right here where it says minus the sum of the area of a triangle. So I'm going to add together 38.5, 4, 30, and 4.5. And you'll see that in parentheses here, and that gave me 77. And then I'm going to take that away from 130, and I end up with an area of 53 units squared. In this problem, you have two figures put together that you're going to find the area of each and then add them to get the entire area. Can you tell what the two figures are? Obviously, one is a square because we can tell by the tick marks that the sides are congruent. And the other is half of a circle. So I'm going to use the formula for a square, which is side squared, to find that area. And then I'm going to use the formula for a circle, but I'm going to put a 1/2 in front of it since it's half of a circle. So I'm going to use 1/2 times pi r squared. Now the trick here is to notice that 6 is the radius. And so that helps us with our circle formula. However, we're also going to use that for our square. So if the radius is 6, then the diameter is what? Right, the diameter has to be 12. So I'm going to use 12 squared to find the area of the square. So take a minute, find the area, and then check back. So here are the steps where I found the area of half of a circle to get 56.5, and I had to round to the tenths there since that's an infinite number. And the area of the square is 144, and then I add the areas together to get a total area of 200.5 units squared. Now let's look at the next problem. In this problem, we are trying to find the area of the shaded region. So what that means is we have a circle that has two circles cut out of it. So we need to find the area of the entire circle, that's the big circle, and then we want to subtract the two little circles. Now notice that the two little circles have the same radius, therefore they're going to have the same area. So we're going to use pi r squared for our formulas for both. However, I'm going to put a 2 in front of pi r squared for the little circles. I'm going to find the area of the big circle, and I have to use the radii for the two small circles in order to determine this. Therefore, I'm going to notice that the diameter of a little circle is the same as the radius of the big circle. So what would the diameter be? If you thought it was 8, you were correct. So I'm going to use pi 8 squared for the big circle. And then what was the radius for the little circle? 4, correct. And notice I put that 2 in front of the pi r squared. Since there's two circles, it just makes the math go faster. And now use your calculator and check back. The area of the large circle should be approximately 201.1 units squared. The area of the two little circles should be approximately 100.5 units squared. And when you subtract, you end up with an area of 100.6 units squared. Notice I'm rounding to the tenths throughout. Here we're finding the area of the shaded region, so you're going to find the area of a rectangle. So you're going to use base times height, and we know that the height is 10. how could we find the base? Well, we know that the circle's diameter is 10. Therefore, the radius is 5. And that's going to give us the width of the rectangle. So we're going to have 20 for the width of the rectangle. And then we have two circles that have the same radius. So we can just use 2 times pi r squared, where what was the radius? 5. Good. So go ahead and solve this one. Remember, you're subtracting the circles from the rectangle since you're looking for the shaded region, and check back. So you should end up with an area of 200 for the rectangle, and the 2 circles combined have an area of 157.1 rounded to the nearest tenths, and when you subtract, you end up with a difference of 42.9 units squared, which is the area of the shaded region. This figure is much trickier. Here we have a rectangle in the middle, 2 smaller rectangles on the side, and notice they're the same rectangles, and then 2 quarter circles. So we know that this is 8 and this is 8 because opposite sides of rectangles are congruent. 32 minus 8 will give us this length right here. So 32 minus 8 is going to be 26, 24. And then we know the radius of each circle is 8. And since both of those have the same radius, they're the same circle. And since they're each a quarter of a circle, that actually gives us a half of a circle. So here's a circle split into 4 pieces to help you visualize a quarter of a circle. So we have 2 quarter circles that have a radius of 8 each. So let's just start putting all of this together. Let's start with the big rectangle. So we have 24 by, well, this here is 12, and then we have this radius here of 8. So the height is going to be 20. Then we have 2 small rectangles that have a base and height of 8 and 12. Then we have a half of a circle. So that's going to be a half times pi times a radius of 8. So see if you can complete this problem and check back. So here we have our half a circle with a radius of 8, so we get 100.5 for the area. The 2 little rectangles, 2 times 8 times 12, gives us 192, and the one big rectangle is 20 by 24, which gives us 480. The sum of these areas is 772.5 units squared. In our last problem, you're going to find the area of a quarter of a circle plus a half a circle, and we're going to use this radius of 8 to determine the radius of our quarter circle. So if the radius is 8 of our half circle, then the diameter of our half circle is also 8, and the diameter of the half circle is the same as the diameter of our quarter circle. So see if you can determine the area of the half circle plus the quarter circle, which are different sizes, so they have different radiuses. And I said this wrong. This is a diameter of 16 because it's double the radius of 8. Find the area of the quarter circle and half circle combined and check back. So we have the area of a quarter circle and an area of a half circle. So the quarter of a circle has a radius of 16. So that's actually the bigger part here. And that gives us an area of 201.1 rounded to the tenths. The half circle, the smaller circle, has a radius of 8, and that gives us 100.5 units rounded to the tenths. And when we add these together to get the area of the entire figure, we end up with 301.6 units squared rounded to the nearest tenths. Good work.